Hello guys, today we are talking about the harder differentiation in the AS mathematics. Okay, so moving to the first part of it. So here you can find that the equation is y equals to a times x power of n, and we have said that dy over dx means the differentiation of y equals to n. So we put n in front at the very front of it. Again, the n becomes n minus one. Okay, so here it becomes n times a times x power of n minus one. So for example, like y equals to 4 times x cubed, we can just put first 3 in the very front of the beginning. So here is 4 times 3. And then power is minus 1. So here is for 4 times 3, then times x 3 minus 1. Okay. So for the equation here, we can say differentiation equals to 12 times x squared. Okay. And we can say here that the differentiation of it always bigger equal than 0 is a non-negative value, right? So it's an increasing function, right? Okay. And just trying to understand it here, like sometimes the power is not a very normal or very good positive number. Like here is for 4 times x power of negative 3. So for this, probably has to first trying to put negative 3 in the very front of this. So here, put negative 3 in the front. So the differentiation here is for 4 times negative 3, and power minus 1 is 4 times 3, then times x power of minus 3 minus 1. Okay, so here it becomes negative 12 times x power of negative 4. Okay, and also if the power here is like a fraction number, so don't be worried about this. Just consider in the same way. So just consider here a is 4 and a times x power of n, then differentiate it. Okay, so here's for n times a times x power of n minus 1. Okay, so here we can say first just put a half, or like here is an n in front of this, so it's 4 times a half, and then power minus 1, that is for x times negative 1 over 2. Okay, so we can say here, so finally the differentiation is for 2 times x power of minus or negative 1 over 2. Okay, that is a differentiation for this. So here's about some examples for hard differentiation. So let's begin it together. So for the first problem, x power of negative 2 and minus x power of negative 1. So we can say first, just trying to put the power in front of it. So dy over dx equals to negative 2 times x power of negative 3, right? So negative 2 minus 1, that is x negative 3. And minus x power of negative 1, you can first put negative 1 in front of this, is minus negative 1 then times x power of negative 1 minus 1, right? So here the differentiation can be considered as negative 2 times x power of negative 3 and then plus 1 times x power of negative 2, right? That is for the first problem. And for the second problem, we can say here, the differentiation for it is dy over dx equals to first just trying to put a half in front of this, is a half times x power of negative a half. And then the second is first we trying to put the power in front of this, is 3 over 2 times x power of a half. Okay, that is the equation. And also here we can just consider like all the equation like 4 over x squared. We can just first trying to change the shape for it, like 4 times x power of negative 2, because x squared equals to or 1 over x squared means x power of negative 2. So here we can set 1 over n the power of a the power of n, it can be considered as a power of negative n. Okay, so that we can use in the equation, right? So for example, like if you want to differentiate 4 over x squared, we can say first trying to translate it into 4 times x power of negative 2. And then we can say just moving the power in front of it, it becomes 4 times negative 2, right? And then power minus 1, that is x power of negative 2 minus 1. So here it becomes negative 8 times x power of negative 3. Okay, that is for this problem. And also for the second exercise, you can just trying to first differentiate about it. So x can be considered as x power of 1, and 1 over x can be considered as x power of negative 1, and 1 over x squared can be considered as x power of negative 2. So for the first differentiation, we can set first just put power in front of it. So it's 1 times x, then it's power minus 1, right? It's 1 minus 1. And the second, we can first we just trying to understand or just put the power negative 1 in front of this, is plus negative 1, and then power minus 1 is x power of negative 1 or minus 1. Okay, so then the third is for first put power in front of this and then make the power minus 1, so it's negative 2 minus 1. So here we can set the power, where the total equation can be considered as 1 minus x power of negative 2, and then minus 2 times x power of negative 3. Okay, that is the final answer for this problem. Okay. And also here's an exercise for you. So if you want to try yourself, you can pause the video and do it yourself. But if you follow with me, you can keep on going. So for the first problem, we can set x cubed can first trying to put 3 in front of this 3 times x power square, okay? Or the second one is for -1, right? And the x minus 1, right? So here we can say that is 3x squared minus x power of -2, right? And for second problem, we can set first trying to just translate into other form like 3 times x power of -3 and then minus 2 times x -2 and then plus x minus 1, right? So here we can set 3 times x power of -3. So first we can try to put -3 in front of this as 3 times -3, right? And the power minus 1 that is for -9 times x power of -4. And for second term is -2. First we times -2 is for plus 4x, and the power here is -2 minus 1 is -3, right? And for second form, we have the last form is like -1 first we put in front of it is minus x, and minus 1 is for x power of -2, right? But that is for the final equation of this, okay? So that is for the second problem. Okay, and always understanding like here for like square root n of a, you can set as n a power of 1 over n. Okay. So also like these problems, like first you want to differentiate like this y equals to x square root, you can set that first trying to translate into y equals to x power of a half, right? So that first trying to make the power in front of it, so it's a half x, and then power minus 1 is half minus 1. So the power here, or the differential here, is a half times x power minus a half, okay? That is for the first problem. And for the second problem, we can set differentiation, right? So first we can just turn it into y equals to 2 times x power of a half, and then plus x power of negative a half, and then try to differentiate it. So dy over dx here can be considered as, so first power in front of it is for 1, and the power of minus 1 is x power of a half minus 1. And then the second form we can say is for minus a half times x power of negative a half then minus 1, right? So here the differentiation can be considered as x power of negative a half and then minus a half times x power of negative 3 over 2, okay? That is for second problem. And for last problem, we can say here x power of a half and plus x power of 0 over 2. First, we can just try to put power in front of it is a half, then times x a half minus 1, that is power of a half minus 1. And for the second differentiation, we can say here x power of 3 over 2. First, we can put 3 over 2 in front of it, that is 3 over 2. And then we can say the power minus 1, that is 3 over 2 minus 1. So first is a half times x power of negative a half, and then plus 3 over 2 times x to the power of a half. Okay, that is for this problem. Okay, that's that for today's our lesson. Hope you can understanding for totally about the Harder differentiation and how to calculate this are very important. Sometimes the negative value or power equals to a negative value or power equals to a fraction number, they are very important for us to remind it. Okay, so next time, bye.